Welcome to this video presentation on the ChemiNova project, designed to give you some context ahead of the upcoming focus group activity. In this short video, we'll guide you through the key elements of the project and the digital tools we are currently developing for cultural heritage monitoring. We are very glad to have you with us and truly appreciate your participation in the focus group. Your feedback will be essential to help us improve and refine these tools. Before the discussion session, this video will provide you with some background on ChemiNova, an overview of what has been developed so far, and a clear explanation of what we expect from you. Let's begin. ChemiNova is a research and innovation project funded by the European Union's Horizon Europe Framework Program. It focuses on novel technologies for on-site and remote collaborative enriched monitoring to detect structural and chemical damages in cultural heritage assets. Who is behind ChemiNova? Behind ChemiNova is a multidisciplinary team, bringing together people with a wide range of backgrounds, skills, and expertise. From conservators and cultural heritage professionals to scientists, developers, and digital innovation experts, we are united by a shared commitment to make a concrete impact in safeguarding our shared heritage. This diversity is our strength. It ensures that the tools are not only cutting edge, but also truly aligned with real-world needs and the everyday challenges of heritage conservation. Our consortium includes universities, research centers, cultural institutions, NGOs, and both technological and cultural and creative small and medium-sized enterprises from across Europe. It also benefits from the participation of ICRAM, the International Center for the Study of the Preservation and Restoration of Cultural Property, an intergovernmental organization that brings a global perspective to the project and is pleased to coordinate the focus group activities. ChemiNova is a project driven by a shared vision to make heritage conservation more effective, inclusive, and forward-looking in the face of today's growing challenges. This is made possible through applied research, innovation, and collaboration. We follow a participatory approach, where tools are validated and continuously improved based on feedback from end users. Our goal is to ensure that everything we develop is practice-oriented and truly responds to field needs while also contributing to scientific research, public engagement, capacity building, and awareness-raising activities with communities to safeguard our shared heritage. ChemiNova aims to develop an innovative suite of digital tools to support heritage professionals in the conservation, analysis, and monitoring of both movable and immovable cultural heritage assets. By integrating a set of non-destructive technologies for damage assessment, the project offers effective solutions to support conservation practices, with a particular focus on two major human-induced threats to cultural heritage: climate change and armed conflict. The goal is to facilitate the work of heritage professionals within a single framework and to support their collaboration through a multidisciplinary approach to documenting, digitizing, inspecting, and exchanging information on cultural heritage with the aim of having a tangible impact on conservation practice. 4 pilot case studies were selected for the development of the project to encompass different types of heritage assets as well as a broad range of materials, contexts, and threats. Several data acquisition sessions were carried out using a range of sensors and technologies to assess the conservation conditions of the selected heritage assets. These pilot case studies also serve as real case testing grounds for our tools. Through collaborative sessions, we can gather direct feedback from the field and continuously refine the tools through an iterative process. The case study in Vienna is the Schönbrunn Palace UNESCO World Heritage Site and one of Austria's most visited cultural landmarks. Our focus here is on climate change impacts affecting both the palace's monumental architecture and its richly decorated interiors and collection. Although the site is regularly maintained, it offers an ideal context to test our tools for environmental long-term monitoring and documentation of movable and immovable heritage. In Valencia, we focused on the site of Lanao, the historic building of the University of Valencia, dating back to 1488 and is prime example of Valencian architecture and houses important collections. Following the Dana flood in October 2024, which severely affected the region, this case study clearly demonstrates how our tools can be applied in a real-world context in response to extreme climatic events. Palermo includes 2 different case studies. First, the Library of Human Anatomy, with its extraordinary collection of wax anatomical models, historical and archival documents. These materials are fragile, sensitive to temperature and humidity, and require careful, continuous monitoring. Second, a historic music pavilion that reflects the challenges of preserving built heritage in complex and polluted urban contexts. In Kiev, we focus on the Cathedral of St. Sophia, a UNESCO World Heritage Site featuring the most extensive and best-preserved collections of mosaics and frescoes from the 11th century. This case study allows us to address another major human-induced threat to heritage: armed conflict. Our work here focuses on developing solutions for remote collaborative documentation and condition assessment in emergency situations, especially when access to the site is limited or unsafe. ChemiNova is a suite of interactive and interconnected digital tools designed for monitoring. The goal is to ensure seamless integration across the suite, offering innovative functionalities to end users. Let's now introduce them one by one. ChemiModel enables the creation of E3D models, that is, enriched 3D models of cultural heritage assets. We call them enriched because they combine multiple scans captured with different sensors, and they're enhanced with data and annotations provided by heritage professionals, all integrated into a single 3D model. This allows you to detect material deterioration, identify potential structural damage, and support condition assessment at a specific point in time. To create an E3D model, here's what you'll need to do. First, collect your data on site. Use 3D modeling sensors like an RGB camera, an iPad with a LiDAR scanner, or a drone. You can also use additional sensors such as reflectance transformation imaging or thermal cameras to get a detailed, multi-layered understanding of the asset's surface. Second, geolocate your object. Third, create the 3D model. You can use open source or commercial software like Reality Capture or Agisoft. Fourth, overlay the different layers or textures into your 3D model. This step can be automated for small objects, but for larger or more complex structures like buildings, you might need to do it manually or adjust it to fix any inconsistencies. Finally, your E3D model is ready. You can now upload it to the ChemiNova database. Use it across the project's tools and enrich it with annotations, condition assessments, and other types of data. ChemiAI integrates artificial intelligence into the conservation workflow. This tool enables the automatic recognition and classification of different damage types using machine learning algorithms. It is designed to support and accelerate the work of heritage professionals by generating pre-visualizations of possible damage areas. ChemiAI is designed as an offline tool, so you'll need to follow this workflow to use it. First, generate the E3D models offline. Second, create training samples by annotating parts of the E3D models offline, using a 3D model software, based on a classification of different types of damage. Third, train ChemiAI and apply it to the entire E3D model offline, transferring the resulting damage class labels onto the E3D model as an additional information layer. Fourth, use the interactive tools on site. In this context, the results from ChemiAI provide an extra layer of insight. For example, you can use it as a guide to take a closer look at areas flagged as damaged by the ChemiAI, and then decide whether the AI's assessment corresponds to reality or not. ChemiPortal is a web-based platform accessible, for example, from your laptop. It serves as the entry point to the ChemiNova digital environment and allows users to explore all the cultural heritage assets in the ChemiNova database, including the 4 pilot case studies presented earlier. You can view all the heritage assets stored in the ChemiNova database. You can display them on a map and filter them using various criteria, such as country, material, or type of cultural heritage. If you are a specialist, you can add your own cultural heritage asset, contributing to the enrichment of the platform. If you are a responsible party or have the necessary authorization, you can create a collection of multiple objects. You can create a site. In your personal account, you can also create your own custom lists of assets. You can view and edit the general information of a cultural heritage asset. You can upload documents such as archival records, historical photographs, or other materials relevant to the understanding of the asset, which will always be available and accessible for consultation. You can view all the condition assessments carried out over time in chronological order. You can carry out a new condition assessment. This allows you to easily monitor the asset's conservation status and make informed decisions for future actions if necessary. You can add an enriched 3D model. In the condition assessment section, once you've created your E3D model, you can create and fill out an associated condition report. In the condition report, you will be asked to complete various sections such as general information, description, diagnosis, survey information, and contributor, enabling a collaborative platform. In the end, you will also be able to download the condition report. ChemiAnalysis is a desktop application that supports professionals in assessing the condition of cultural heritage assets. What can you do in ChemiAnalysis? You can access the ChemiNova database and search using a range of filters. You have access to all available data related to the cultural heritage assets stored in the ChemiNova system. You can inspect high-resolution enriched 3D models and switch between different textures to visualize various information about material characteristics. You can view existing annotations, create new ones, and add information on observed damages. You can open and explore multiple cultural heritage assets. ChemiInspection is an application designed for use in the field through handheld devices such as tablets. It supports on-site inspection of cultural heritage assets by using augmented reality to guide professionals through inspection procedures. What can you do in ChemiInspection? First, you can connect to the ChemiNova database and search using filters. Second, you can access all available data about the cultural heritage assets. Third, you can visualize overlaid information directly on real-world objects and add real-time annotations to E3D models, making condition assessment more effective and interactive. You can record observations, annotate types of damage, and generate condition report. ChemiSensing creates an immersive environment for collaborative work, enabling on-site and remote heritage professionals to jointly inspect and assess cultural heritage assets. This tool facilitates collaboration among multidisciplinary teams, allowing each member to view the same heritage asset in real time, whether with a desktop, mobile device, or VR headset. It's teamwork redefined for the digital age. What can you do in ChemiSensing? First, you can connect to the ChemiNova database and search using filters. Second, you can access all available data about the cultural heritage assets conveniently in one place. Third, you can inspect and interact with 3D models. All users can collaborate across different platforms, join the same session, and make decisions together. Finally, let's talk about our last Chemi tool, very different from all the others. We're talking about ChemiC. It's an open-source, web-based platform designed to connect people and communities with their cultural heritage, engaging them directly in its preservation, and fostering collaboration between heritage professionals and non-experts. ChemiC is inclusive and accessible to all. It adopts a narrative, artistic, and playful approach to raise awareness about the impact of climate change on cultural heritage. Everyone can choose a character to identify with and take part in an interactive journey. Along the way, people will be invited to contribute by sharing photos or other information about a heritage asset that matters to them. Because in ChemiC, everyone has a role to play. As a participant in the upcoming focus group, your role is crucial. Your contribution will help us shape the final versions of these tools and ensure they are truly aligned with the needs of the heritage community. During the focus group, we will discuss your impressions by asking both general and more specific questions to guide the conversation among all participants. We've now reached the end of this presentation. All the ChemiNova teams want to thank you so much for your participation in this process. Your time, expertise, and experience are extremely appreciated, and we truly look forward to hearing your thoughts during the focus group. See you soon.